Hello, I'm John Lincoln, Chief Executive of the Photonics Leadership Group here in the UK. And today I'm going to be talking about the scale and growth opportunities for photonics in the post-COVID era. Looking first at how the environment, especially here in the UK, has changed, and then look to see how this influences some detailed challenges and opportunities. So how has the environment changed? Well, back in 2017, the UK had an industrial strategy that emphasised things like clean growth and healthy ageing. Already 2 years ago, we had broken that up in 7 different areas of influence over future opportunities for photonics. But what's really interesting is to see how those have changed in the last 2 years and what we can look forward to in the post-COVID era. So, for example, health, we know, obviously been very much in the focus, but of course the shift is now between health of all ages and in particular catch-up. How in the UK do we catch up all those waiting lists that have risen hugely because of COVID? But also we see that the health service here in the UK and globally has moved heavily to remote care and adopted huge amounts of innovation in a very short space of time. In transport, we see a shift from how soon will autonomous vehicles arrive to what's the balance between commuting and home working. In data, we've seen a shift to connectivity again. How can we connect? How secure is our connection? Who's connecting us? Will we have the connectivity we need at home? We see a similar continuing emphasis on physical pollution, but we also see a subtle shift in climate change and sustainability. In the policy environment, we see a big shift towards people talking about net zero targets and the pathways for achieving net zero. And simultaneously, we see companies really adopting sustainability strategies, appointing sustainability champions to their boards. In defence and security, of course, it's still a lot of emphasis on affordable and agile, but certainly here in the UK, we've seen an increasing emphasis on how do you invest to develop generation after next capability. And already in 2019, there was a lot of emphasis on deglobalization and sovereign capability and uncertainty. Well, of course, we now all know about uncertainty, and so the shifting emphasis has been to resilience and national capability and cautious collaboration. So, how's the policy agenda developed in the UK? Well, back in the budget earlier in March this year, we had a Build Back Better strategy alongside the budget. This was really a nest of policies that have started to emerge in the following months, starting with an integrated review that was to do with building strategic advantage through science and technology. And then in July, we had a new innovation strategy. Out went the industry strategy, and now we have an innovation strategy with a focus on 7 transformative technology families critical to the future of the UK, with photonics front and centre as one of the key ones in there in one of the families, along with electronics and quantum. And then, of course, we had an R&D places strategy and R&D and people and culture strategy. So we see a whole raft of these, and they will continue to emerge. But it's certainly very pleasing that photonics has been identified in that innovation strategy. That will be followed by a spending review that appears in November this year, actually end of October, so very soon, which will set departmental budgets for the next 2 years in the UK and try and find a balance between spending and the costs coming from COVID. But what you see, and I'm sure will be true in the spending review, is net zero is all pervasive in all of these strategies and the UK government's policy going forward. So what does this mean for photonics? What are the specific challenges? What opportunities does it present? So let's look at healthcare. Well, I already mentioned that there are some challenges in healthcare. Always, photonics has had to fit with healthcare pathways. There's no point in coming up with an innovation that totally disrupts how clinicians undertake their day-to-day work and interaction with a patient. Photonics is also only a fraction of the cost. Healthcare systems are complicated and they're heavily integrated. But we also have this challenge that having adopted a huge amount of innovation in a short space of time, how much will healthcare systems have the capacity to absorb yet more innovation? Have they used up all their bandwidth? And indeed, what bandwidth will be available when they're very much focused in the near term on reducing waiting lists? There are, of course, though, plenty of opportunities, especially in real-time diagnosis and testing, point-of-care testing. We know from all the testing that's been done for COVID, it's now very much in the public mind, and there will be huge growth, I believe, through the use of integrated photonics in this area. But we mustn't forget the use of photodynamic therapy and other photoactivated drugs, as well as precision surgery. I would perhaps question, will we see the growth of lifestyle monitoring devices that was perhaps forecast 2 years ago? And then, like for transport, well, the challenges for photonics in here are not whether autonomous vehicles will be a reality, but the unpredictable timescale for adoption. And I think what we've certainly seen is the market move from rapid full autonomy to driver assistance systems. But again, the question is, when will they appear, in what range of vehicles, and at what volume? And of course, you have these technical challenges of range versus safety versus weather. We of course live in the UK. We have rain. We need systems that work in the rain. We need systems that work on roads that are being dug up and repaired. But that's not the only aspect. As we move and see a big increase in electric vehicles, which is happening right now, we're seeing a big change in the materials that they're manufactured from. And that presents challenges because the traditional manufacturing methods change, but huge opportunities. And so in that opportunity space, we see all the sensing stuff, 3D sensing, what's in your location, LiDAR, real-time speed monitoring, etc. But also in laser manufacturing, and in particular the processing of dissimilar materials, both in the powertrain, the batteries and the e-motors, but also in the structure. And we mustn't forget that when I talk about transport, I mean in air, sea, rail, trucks, cars, all of the areas. So that composite structures we're more familiar with in aerospace perhaps, but will become more common in ground-based transportation as well, and present a number of opportunities for how those are joined and welded and marked in the manufacturing process. And then communications data. Well, looking forward, one of the great challenges and opportunities here is about latency. What we've seen is that connectivity in the last 2 years has become an essential service. But what we know is that going forward, remote healthcare, gaming, autonomy, finance, all of these things are latency critical services where you're not just absorbing data in one direction, it's a two-dimensional exchange of data where you care about the round trip the data takes to get from you to whichever data center it's processed in and back. That is latency, and will be, I believe, a big focus on not just bandwidth, but bandwidth with latency. We also have this challenge that we all want more bandwidth and lower latency, but we don't really want our costs to go up as a consumer. So we must provide more capability, more bandwidth, without the cost scaling linearly. And one of the things that will mean is optics gets much closer to the customer and the processor at each end. So instead of just being in the trunk network, the optics get closer and closer to the desk. And I'm privileged to have a fiber connection that comes within a few centimeters of my desk. And at the other end, the optics will get closer and closer, not just to go into the data center or the rack in the data center, but very close to the processor itself. So that leads to lots of opportunities in integration, on-chip, in-chip, at volume, new types of optical fibers, new types of optical amplifiers, but also challenges and opportunities around domestic production higher in the value chain. We already make, in compound semiconductors, vast numbers of the lasers used in the communications industry. The base wafers start life in the UK, but we need to go up that value chain and capture more of that value. And then there's the whole area of quantum communications, and being ready to adopt that whenever industry needs. And then there's consumer photonics. Well, one of the interesting things if you design things for the consumer is that the same challenges, bizarrely, you often see in the defense industry. It's all about size, weight, power, and cost come in. It's just that their definition of what is an acceptable size, weight, power, and cost are much smaller. But what's really interesting in this space, it's not the size of the opportunity. These opportunities are all enormous, but the timing. You must go from 0 to hero volumes with almost no market in the middle. There's no opportunity for 1,000 devices or 100,000. You either make 1 million or none, and you have very short product life cycles. So there's plenty of opportunities in 3D sensing, augmented reality, gesture displays, and integration, whether that's in comms or in health or transport, which you also need, but also in the devices themselves. But we must deliver price, volume, price, and volume. Then a theme I particularly want to emphasize is photonics for net zero. And here there are three key areas photonics plays. First of all, in generation. Okay, photovoltaics are the obvious one, and more efficient photovoltaics, more flexible photovoltaics for integration into buildings. But there's also an enormous contribution that can be made from improving the efficiency of other forms of power generation, for example, wind turbines. Quick calculation will show that if you could improve the efficiency using LiDAR of wind generation by just 2%, you could possibly avoid globally building 5 nuclear power stations. That's a very big impact because of the scale available. On the other side, photonics has an enormous role to play in the use and productivity of how we use our energy. So in communications and data, going back to that theme, data centers already use a significant percentage of global energy, and that is increasing as the digital economy grows. So we have a dichotomy. Digital economy growing, data use growing, but we need the energy and carbon emissions from that digital economy to go down. That requires double motivations for innovation. And in industry, lasers and machine vision are key to smart manufacturing, Industry 4.0, and that tightening the control feedback loop within smart manufacturing is an area photonics has a key role. And we mustn't forget lighting, of course. I'm not going to emphasize it very much today, but lighting, LED lighting, is much more efficient than traditional forms of lighting, but we will also see the emergence of smart lighting, lighting that knows how light it is outside and then decides to turn on only when you need it. So those are two key sides, but one additional area that photonics plays a big role in net zero is in resource use, materials. So there's a double level of challenge here. Photonics uses lots of packaging because optical surfaces are sensitive, and we have lots of complicated material combinations that make recycling, reuse, and the circular economy inside photonics harder. But there is also many opportunities for photonics testing and being used as the mechanism by which you can verify what material is and how it can be reused outside of the photonics ecosystem in the much broader manufacturing world. So, net zero, I would like to emphasize, is a real 21st century challenge. It is truly global and all pervasive. It goes over all markets. It doesn't matter whether it's consumable use in healthcare or transportation. But it's also a headline. It's not a manual. It has many dimensions and indeed some contradictions. For example, what do you do with an innovation that is more energy hungry in its manufacture, but then uses less energy in its production? Is that good or bad? Well, that might depend on its lifetime. So what do you do with, say, a new communications innovation that is better in terms of energy use, but has a shorter lifetime? Is that good or bad? So these things we'll have to come to terms with over the next few years. But the thing I really want to emphasize is photonics must be part of the solution. It is vital to appeal to customers, to investors, but really to employees. If you want the next generation of people to come and work for your company, photonics must be part of the solution. So that's all I want to say today about the emerging opportunities in photonics. Once again, we are the Photonics Leadership Group, trying to nudge industry, academia, support agencies and government together to make photonics bigger, faster, stronger. Do get involved. My details are here. But also, we have a new UK-wide photonics directory of all organisations involved in photonics, and you're very much welcome to go onto the photonicsuk.org website and claim your entry in the photonics directory. Many thanks.